Consider the curve given by x, y squared.
Can I sit in my chair?
Yeah.
And can I have my answer key? Do you have it?
Okay. Thank you.
Okay, so we're gonna do this problem together. Those of you guys who didn't understand that one. Okay. Thank you. Okay, so it says consider the curve. Now when I say consider the curve, what do we know about this curve? Is it a function necessarily? Not necessarily, right? It's a curve, which means you can graph it, but doesn't mean that it's gonna pass the vertical line test, okay? Because it could be, for example, something like x squared plus y squared equals 9. That's a curve. In fact, what is that? That's a circle, right? But so it is a curve, but it's not a function, okay? So consider that curve. First, you have to show that the derivative equals that. Raise your hand if you needed help on how to prove that. I think most of you guys were able to do the first step. So what kind of differentiation do we need to show that the derivative is this? Implicit differentiation, that's right. So I'm going to use implicit differentiation. You got here, and then you do some, algebraic gymnastics, and you were able to show that the derivative when you use implicit differentiation is that. Okay, now that's the easy part. Now here's the more tricky part. It says find all points on the curve. Which curve? This curve, right? The original curve. Find all the points on that curve. By the way, can I call this f of x?
Yeah.
No, because it's not a function, not necessarily a function, right? Like, can I call this f of x? No, f of x means it's a function where if I input one x, it'll only give me one y. But if I input an x here, I could get more than one y possibly, right? So it's not f of x, so it's a curve. That's why we call it a curve instead of a function. So it says find all the points on the curve whose x-coordinate is 1, okay? And write an equation for the tangent line at each of these points. So before I start doing this problem, sometimes I like to have a picture of what is happening. Now, it's not a graphing calculator problem. I can't graph this on my calculator. Even if I was allowed, I don't know how I would put that into my calculator. Desmos can graph it actually, but not TIs, because TIs you have to put in y1. You have to solve for y first, and if I wanted to solve for y, that's just hairy. Okay? So basically, let's just imagine that there's a curve like this. Okay, let's say I graph it and it looks something like this. That's the curve. Okay, it's like crazy. They want me to give all the points on the curve whose x-coordinate is 1. Let's say this is 1. Okay, so according to this crazy thing that I drew, how many times on the curve is the x-coordinate 1?
3.
One's here, and one's here. There's 3 points, right, where the x-coordinate is 1. So what do they want? They want the xy coordinates. They want the points where x-coordinate is 1. So this is 1, 1, 1. And they want me to write an equation for what? The tangent lines. Okay, so basically they want 3 different equations of 3 different lines. Okay? But the only thing they told us about these lines is what? That the x equals 1. Okay, they only told us that the x equals 1, but what do we know? We know that the x equals 1 on this. We can plug in x equals 1 into this curve to find what? The y value of that point. And we could also plug in x equals 1 and the y that we figure out into this to find what? The slope of the tangent. And ultimately, we need to find an equation of the line. To find an equation of the line, we need 2 things. What do we need? The slope and the point. And I could find the point by plugging my x equals 1 into here. And I could find the slope by plugging in x and y into my dy dx. Okay, does that make sense? Okay, so let's begin. All right, if I know that x equals 1, I'm going to plug in then on the curve, okay, the original curve, I'm going to say 1 times y squared minus 1 cubed times y equals 6, which means that y squared minus y equals 6. I'm trying to solve for y, so what I'm going to do not try to factor yet. What should you do? Move everything to one side. So y squared minus y minus 6 equals 0. And if conveniently, I can factor that. y equals what?
Negative
2 and positive 3. So that tells me that there's 2 points when x equals 1. There's 1 comma negative 2 and there's 1 comma 3, right? Are 2 points on the curve. So this picture was a little wrong because there's actually 2 points, right? When x equals 1. Okay, so that I solved the first, I responded to the first part of the question. But now what do I have to do? I have to write an equation for those lines. I have a point on the line, and now I need a slope. And how can I find the slope? By plugging it in. That's right. dy dx when my xy equals what? Let's do 1, negative 2. You see how I have to label? Otherwise, if you just start doing stuff, they're not going to know what you're doing. So let's find the slope when xy equals 1 comma negative 2. Well, they already told me from the beginning what the formula is, right? It's this guy. So I'm going to plug in 3 times 1 squared times negative 2 minus negative 2 squared all over 2 times 1 times negative 2 minus 1 cubed, which is negative 6 minus 4 over negative 2 minus 1. Is that right? No, negative 4 minus 1. So that's negative 10 over negative 5, so it's 2. So what's my slope at the first point? 2. So therefore, what is my tangent line? Y minus negative 2 equals 2 times x minus 1. That's my first equation, right? Or you can say y equals 2x minus 1 minus 2 if you want, right? The other slope when xy equals 1 comma 3 is going to be 3 times 1 squared times 3 minus 3 squared all over 2 times 1 times 3 minus 1 cubed, which is going to be, what is this, 9 minus 9 over 6 minus 1 equals 0. So it's going to be y minus 3 equals 0 times x minus 1, which means y minus 3 equals 0, which means y equals 3. Okay? Let me just show you. I was doing this problem with Daisy the other night, and we happened to graph it on Desmos. Huh? I don't remember. So the graphic, it's free. Desmos is free. So what you can do is you can actually put the curve x, y squared. You don't have to solve for y with Desmos. That's the beauty of it. X cubed y equals 6. Woo! Look at that graph. It's crazy. That's the graph. But when x equals 1, let me just put in x equals 1. When x equals 1, the graph intersects with x equals 1 twice. Once here at 1 what? According to what we discovered. 1 comma negative 2 and also at 1 comma 3. And what's the equation of this tangent line? Y equals 3. And what's the equation of this tangent line? Y equals 2x minus 1 minus 2. That's what we just found. Get it? Isn't that crazy? That's pretty cool. Okay, now here's the trickiest part of them all. Okay, are you guys with me? The trickiest part of them all is they said to find the x-coordinate. This is a sneaky 2000. Wow, I took the AP test in 1999. So the year after me, no! Oh my gosh, I took it in 2000. This was my AP test. What? Yeah, no, because I graduated. No, that was my junior year. I took it in 1999.
You took AB in 1999.
I took AB in 1999. So the year after me, they put this on the AP test. So I guess my brother took it in 2001. So, anyhow, okay. So find the x-coordinate of each point.
Attention students, you have approximately 5 minutes remaining in lunch. Go ahead and use the restroom. Clean up your area. Once again, approximately 5 minutes remaining in lunch.
Find each x-coordinate of each point on the curve where the tangent line is vertical. now that we can cheat a little bit and we have the graph, we want to look for vertical tangents. According to this, can you find any places where the tangent line looks vertical? Like what about right here?
Close to 0.
Maybe over here you think the tangent line might be vertical?
No.
No? Like right here.
Where?
Like right here. Don't you think there might be a vertical tangent right here?
Oh, yeah.
And then maybe you're thinking over here. Okay, so what do we know about vertical tangents? Well, here's the slope of the tangent. And vertical lines, the slope is what? Undefined. When does this undefined? When the denominator is 0. So we want the denominator to be 0. So 2x minus y equals x cubed to equal 0. Okay, we want to find the x coordinates when the denominator is equal to 0, right? And so if I factor out the x, it's 2y minus x squared equals 0. Well, when does this product equal 0? Either when x equals 0 or when 2y minus x squared equals 0, right? But can x equal 0? If you plug 0 into this, you know what you're going to find? 0 y squared minus 0 cubed y equals 6. 0 minus 0 equals 6. Can that happen? That's impossible, right? So that means x can never equal 0, right? That never happens on that curve, right? So that's not even a possibility. So can this equal 0? That can equal 0, but when does that equal 0?
2.
We don't know. So we have to figure out using this original curve when this actually equals 0. So what I'm going to do is I'm going to use substitution basically. I'm going to solve for y, okay? 2y equals x squared, so y equals 1/2 x squared, okay? So basically when y equals that, then my x will be 0. Then my denominator will be 0, right? When y equals that, my denominator will be 0. Well, when y equals that, what is the x value? How can we find that out? Plug this into here, okay? If I plug that into there, I'm going to have x times 1/2 x squared minus x cubed times 1/2 x squared equal to 6. Okay? So I'm going to do some crazy math, and I'm going to get 1/2 squared is 1/4, x squared is what? X to the 4th, minus 1/2 x to the 5th equals 6. So I'm going to have 1/4 x to the 5th minus 1/2 x to the 5th equals 6. Wow. So what's 1/4 minus 1/2? Negative 1/4 x to the 5th equals 6. If I multiply by negative 4 on both sides, I'm going to get x to the 5th equals negative 24. And so if I 5th root both sides, x is going to equal the 5th root of negative 24. Can I have a negative under the 5th root?
No.
Yes, because it's an odd root, right? Because odd numbers to the 5th power give you negative numbers. So that is my answer. And that is actually about negative 2.8, I think. And that is one time where my x value will give me a vertical tangent. Okay? Ah, that was crazy. And so right there, like I told you, about negative 2.8, right there we'll have a vertical tangent. Okay? Now that's a difficult problem. But now that you've seen how that difficult problem works, do you think if you see another similar problem you might be able to do it? Maybe? Yeah? Okay. Alright, so tomorrow we'll continue. That was like the most complicated one. The other ones, make sure you're just ready to explain it to me, okay? And then we'll talk about it tomorrow at lunch, okay?
So we can get the signature?
After school? You can come after school. I'm going to have retakes though. It starts at 4.
So you
Yeah.
start at 4?
Yeah. I have a meeting in 2.
Wait, what time?